All right, again, you guys just getting on. Make sure you're on day 3 in your notes and definite calculator by you. All right, Tuesday, we're sticking with the quiz on Tuesday. The quiz will cover day 1, which is our, I get 2 toothbrushes for I don't know, you guys know what I'm talking about. The eggs, the ice cream, cholesterol problems that you did for me. Nice job on your assignment yesterday, and what we're about to do on day 3. That's what will be covered on the quiz Tuesday. All right, and if everyone follows along with the deal, movie Tuesday, Wednesday, Thursday, Friday before break. All right. Okay, so here's what we got today. We got 4 word problems for you. We are still going to set up 2 equations and solve them. That's it. We're still going to solve 2 equations, just like we did the last 2 days in class. The problem's going to be how you get those 2 equations. All right. First 2 type, I call mixture problems. Mixture. So let's read through this first one together. All right, we're working on a flu vaccine. Hey, good timing, huh? Needs to mix. Okay, I need to mix a 10% solution with a 60% solution. Anybody getting SAT vibes right now? So I got to mix a 10% and a 60% solution together to somehow create 50 milliliters of a 30% solution. So how much of the 10 and how much of the 60 do I need? All right, before we get to the equation, let's make up variables. All right, set up your variables right away. So you pick whatever letter you're fond of. I don't care. I'm going to let x equal, let's see, I need a 10% and a 60%. So I'll let x equal the amount of 10%. Again, you can have x, y, z, a, b, c. Stay away from o. And then it looks like y for me will be the other type of solution, which is the 60%. Okay? So x is how much of the 10% I'm going to need, and y is going to be how much of the 60%. All right, so let's build these 2 equations right now. But before I write down an equation, I'm going to draw a picture of this, because I think drawing a picture is going to help you guys out tremendously writing the equation. So the first type of solution you need is 10%, right? So take a look. Here's my 10% bucket. Here's my bucket with the 10% solution, but I don't know how much is in there because I called it x. All right, so everyone's all right with what's in my first bucket. There's the 10% solution. I don't know how much I have because I called it x. All right, next, I'm going to add that to a second bucket that's got 60% solution. How much 60% solution do we have? No idea. I called it y. That's what I'm trying to find. All right, mix it together. What do I want at the end? If I mix it together. 70%? No, whoa. No. Read the problem, big dog. Read the problem.
50 milliliters.
I need to obtain a 30% solution. So now 30%, but I'm not going to put a variable below because I already know how much I need, which is 50. Yep, good job. 50. So there it is. Everyone see those words being put into a picture right now. 10% x, 60% y, mix them together. You get 30% of 50 milliliters of 30%. All right, ready? Here we go. Now it's time to set up both equations based on my picture here. First equation. Without the percents, I know I need this much of the 10 plus this much of the y to make a total of 50 milliliters. Makes sense. I need so much of the 10 plus so much of the y to make 50 milliliters total. Next, remember yesterday and the day before when we had money involved, I was like, money stays with money. Same thing here. Percents stay with percents. So 10% of x. I don't want to write 10. I always want to write it as a decimal. When I write the equation. So watch. 0.10x. 10% plus Now 60% would be 0.60. Why? Now I'm just putting the percents with them. Equals, how do you think it's going to look on this side now? Just keep going with what I've done here. What's it going to look like?
Equals 0.30.
Yeah, but not just 0.30.
0.30.
Because remember, hey, look, I multiplied it by how much was always in there. So 0.30 times the 50 I already know is in there. So there are your two equations, everyone. How much total I have, and then I work with the percents. Whew. Anybody want to ask anything before I start solving these bad boys? Anything at all? All right, my one suggestion, take your calculator, figure out what 0.3 times 50 is, and then rewrite it in there. Just remember how you got it, though. So we go to the calc, 0.3 times 50, that's 15. So this is 15 here. Again, if you guys erased it or crossed it out, you please make a note to yourself how you got that, 15. 0.30 times 50. Okay, guys, this is the same thing we've been doing the last 2 days in class. Same thing. Eliminate a variable. So I'm going to turn this over to you guys. The first equation you wrote, what do you want to multiply here by? What do you want to multiply here by to eliminate the x's or the y's? You tell me. All right, let's go. Shoom, here we go. That's period 2. How about this period? Ella, what do you want to multiply that first equation by to eliminate the x or the y? Your call. I couldn't hear a word you said. Can you guys hear or I can't? Can everyone hear at home?
No.
Okay, it's all right. It's all right, Ella. It's fine. Okay. I was going to say before I open my mouth. No, not here. Okay, let's try again. Dan, what do you want to multiply the top one by?
Multiply the top one by negative 0.1.
Okay, that's fine with me. Negative 0.10. You could have also multiplied it by negative 0.60. Now look, this is going to sound harsh because it's honest. Some of your handwriting is awful. All right, and I don't complain because that's my job to read it, but your handwriting is awful. You better be careful here. Working with decimals, sloppy handwriting can kill you. All right, it can kill you when working with decimals. So try to be as neat as possible, please. All right, be as neat as possible. All right, so let's take Dan's negative 0.10, distribute. Take your darn time and write it neatly. I feel like I'm talking to my daughters at home. Just, you know what the deal is here. I didn't mean to go parent mode on everyone there, but. Let's see, 50 times negative 0.1, negative 5. All right. The x's cross each other. The x's cancel. Combine like terms now. I get 0.50y. Nice and neat. Use the calculator. Equal to 10. Divide both sides by 0.5. Nice and slow. 20. And I would, just to make things easier on me when I correct it, just go back to your let statement and say, all right, the amount of 60% is equal to 20 milliliters. Done. So 20 milliliters of the 60%, and then you guys go ahead and find how much of the 10% if they has to add up to 50. Should be an easy one for you guys. Well, let me actually ask if it's easy or not. How much do you have here? All right, Ella, here we go. You got it now. Welcome back. I'm gonna say, if I lip read correctly, I'm gonna say you said 30. There you go. Thank you. It's all good. All good. Questions there, guys, on that mixture one. All right, one doesn't make us great. Let's go sell in some tea now. Let's mix some tea together. Anybody enjoy tea in here? Anybody enjoy a nice cup of tea?
Yeah.
Green tea.
Green tea, Isaiah? All right. And
Now and then.
I'm not a tea or a coffee guy, so I don't know what to tell you. All right. So you guys can see we got two types of tea. We're going to take a $6 per pound tea and an $8 per pound tea. Mix it together. And what I need is 144 pounds of $7.50 tea. All right. Let's get the variables done first, right? So my first type of tea is the $6 a pound tea. LB for pound. Little LBs. Y equal to the $8 per pound tea, because that's the other type of tea. All right, here we go with my buckets. If you don't like my buckets, then just write your darn equations. I'm not going to be offended. All right, bucket one. You guys help me out. What type of tea do I have first? Bassett, what type of tea do I have to mix first?
The X one, $6 per pound.
There you go. So I'm going to put, now last problem I had percents. Now I have money. So I'm going to do $6 tea at X. Mix it with Bassett again. What are you mixing it with, Bassett?
$8 per pound.
Good job.
So one.
$8 per pound, which I called Y. Mix it together and tell me what I should end up with after mixing it. There you go, Nick. Good afternoon. Good morning.
Is it the $7.50 per pound?
Yep, but now, Nick, I don't have a variable underneath because I know how much $7.50 pound tea I have to have. How many pounds?
144.
There you go, guys. Make sure that goes in there. I know I need 144 pounds of it. Okay, there's your bucket. Let's write the equation now. Money stays with money. Or you can just tell me how much I need for the other equation. All right, come up with one equation for me now, knowing all this info. One zip. Caroline, going to you. You got one equation for me, Caroline?
Yeah.
Go ahead.
6x plus 8y equals 7.5 times 144.
Good. 6x plus 8y. And this part drives me nuts because kids just forget to do it. They put 144 or they just put 750. You got to make sure you're multiplying everything here. 750 times $1.44. Got to make sure you multiply them. All good? All right, what's my other one then that involves the just the amount I need? No money. No money. Caroline already took care of the money for us. Just the amount I need. Nick, going back to you. What's the other equation? I took care of the money, but I need 144 pounds total.
Is it just the X plus Y equals 144?
That's it. Yeah, you're fine. That's right. Yeah, X plus Y. The pounds of 6 and 8 have to equal up to 144. Yeah. All right, your choice now. No decimals. Yes, right? No decimals. Yay, no decimals. I'm actually just going to cheat real quick. I'm going to write this one on top just so I keep everything straight. X plus Y equals 144. All right, what do you want to multiply the X plus Y one by? Eliminate a variable for me. There we go. Will, what do you want to multiply the X plus Y equals 144 by to try to eliminate something? What do you got for me?
By 6.
All right, if I do just 6 though, Will, it won't eliminate. Because I'll have positive 6x and a positive 6x.
-6.
There you go. Yep, make sure they have opposite signs. So -6, everyone. All right, go ahead. Distribute. We got it. Nice. Take your time. Be neat. Some of you guys, I correct your assignments, and it looks like you had your stylus in your mouth trying to do it. And I'm like, Jesus. Have some self-respect. $1,080 for me. I should probably do 750 times 144, right? Wait, what am I doing here? I'm rattled. Sorry, guys. I'm just rattled. I'm a hot mess right now. Okay, that's 1,080 minus 6y. All right, how about that? We good? Okay, cross off your x's. You guys can certainly go ahead of me. I know most of you are, so I'll catch up here. Should be getting 108 pounds of the $8 tea. 108 pounds of the $8 tea, and you guys can go right back ahead and find how much $6 tea I need. Because remember, it added up to 144. $36 pounds of the $6 tea. Anything I can answer here? So these are mixture types. May involve money, may involve percents like the last one. Questions from you guys at home at all? You good here? All right, last type, motion ones, motion. And these sound just like SAT questions. All right, motion problems. So you got a small plane with the wind, which means the wind and the plane are going in the same direction. It goes 450 miles in 3 hours. But then that same plane goes against the wind. So the plane's going one way, the wind's going the opposite way. It takes 5 hours now to fly the same distance instead of 3. What's the plane speed and what's the wind speed? Plane speed and wind speed. Variables first, variables. I'm going to get away from X and Y because I got a plane here. So I'll go P equals plane speed. And I got a wind, so I'll go W. All right, no little diagrams here. I don't know how many of you, and I don't know if they still do it in science class or not, are familiar with the formula distance equals rate times time. I don't know if anybody's familiar with that or not. That's basically what I'm going to use right here. Okay, so when you go with the wind, when you go with it, I got to take the plane speed and add on the wind speed to it. That's when they're going in the same direction. Whatever the speed the plane is, I have to also include the wind speed because they're going in the same direction. And I know it's going to be 450 miles. I'm going 450 miles. Now, how do I incorporate the 3? I take however long it takes, in this case 3 hours, however long it takes, and I multiply the plane and the wind speed by that. So just to show you, distance, 450, equals rate, P plus W, times time, 3. That's where that D equals R times T comes from. Okay? Now, the same thing's going to happen when I go against the wind, but now I got to subtract it. Okay, the plane speed, and when the wind goes against it, I subtract it. And that's taking me 5 hours now. To go how far? If you read the problem, how far?
450.
How much?
450 miles.
Yeah, everyone see? It flies the same distance, so 450 again. All right, so those are the two equations. With the wind, I add it. Against it, I got to subtract it. And I always multiply it by the time it takes me. All right, let's take our time now. Let's distribute the 3 and the 5 and write our two equations now. 3P plus 3W equals 450. I'm just distributing inside the parenthesis. Inside the parenthesis, I'm distributing. Second one, 5P minus 5W equals 450. I'll let everyone catch up before I talk here. All right, this is a lot different than what we've worked with. Every single problem we've done, we've multiplied, we took one of them, multiplied by a number, and then we were good to go. That can't happen here, though. You can't multiply this top one by a number, and then the P's and the W's are going to cancel. It's not going to happen. It's not. You can't say multiply by -3 or -5. It's not going to happen. Does everyone see that? You can't give me a number to multiply by, so the P's and the W's cancel. So what do I do instead? You give me two numbers now. You're going to have to multiply each of the equations by a number so the P's or the W's can cancel. How are we going to do that, huh? Well, anybody got a suggestion on numbers I can multiply by?
Yep.
Okay, I'm listening, Caroline.
-5 on the top. And then, could you do +3 or should you do -3?
Well, what are you trying to eliminate? The P's or let's stick with the P's, okay?
Oh.
Okay, so let's see.
Okay,
If you got okay, hold on. You got -15P here, +15P here. Looks like it's good. Those will cancel. Yep.
Okay.
So basically, everyone just take a look what Caroline just did. She basically took this number here, put it up here, and just flip-flopped the numbers. And just made sure one was negative, one was positive. It works every time. Works every time. Good job. All right, distribute nice and neat. -15P minus 15W. Distribute all the way through. I'm getting a -30W here. -30W equals -900. So the wind is going 30 miles an hour. All right. So the wind is going 30. All right, you ready for the plane? Take one of the two originals right now. I'll do it here with you. Let's do the top one. Looks the easiest to me, right? Because it's plus. So I take the first equation. W was 30. So I'm going to plug in 30 for W. So 3 times P plus 30. Distribute your 3 and solve. So distribute the 3. 3P plus 90 equals 450. And then you guys can go from there. Okay. And hopefully you guys are getting out the planes going 120 miles an hour. Can I answer any questions before we get to our last motion problem? It's going to work the same way, except we're just not talking planes and wind. We're talking something else, but it's going to work the same way as far as where the distance goes. With, I add. Against, I subtract. All right, what do you say we get it going? Now we're just rowing instead. Instead of flying a plane, we're rowing. So with the current, you guys see what we can do. Against the current, you can only row 2/3 of it in 4 hours. So what's your rowing speed and current speed, as in like the water, not your actual right now speed? All right, so here we go. Well, what do you say? R, kids, for row speed, rowing speed? You guys can do whatever you want, remember. Rowing speed, and then the speed of the current, the water. Okay, turn it over to you guys. Caroline, over to you. When I go with the current, Caroline, do I add the speeds together or subtract them when I go with it? Add them, right? So ready? R plus C. How many miles am I going, Caroline?
24.
In how many, what's the time frame?
3 hours.
So I Yep. So I multiply my rate here by 3. Good. All right, now this is going to get tricky for somebody coming up here. Okay, here we go. Eliana, when I go against it, what do I do with the speeds? Now when I go against the current, what should I do with my rowing and my current speed? When I go against?
Go negative.
So you go R minus C now. How long is it? How many hours does it take me to go against it? Or, yeah. How many hours, Eliana, to go against it?
4 hours.
Okay, so times 4. But now we got to be careful here, everybody and Eliana. I'm not going the same distance, 24. It says you can only row 2/3 of this. So what do I need to do with that 24, Eliana? What do you think? I can only go 2/3 of that.
So divided by 2/3.
Not divided by. That'd give me something more than 24. I want to multiply it.
Okay.
So I'm finding what 2/3 of 24 is, everyone. Okay, what's 2/3 of 24? That's the distance I can row. So you guys might want to find that out first before doing anything. And that's 16. And then I'm going to kind of just let you guys work here. All right, I'm just going to let you guys work. You guys can distribute. Okay, you're going to have to multiply by two different numbers. I'll let you guys do that, and go ahead. Keep working. Give you guys plenty of time, and then we'll see what we ended up with. Whole numbers you should end up with here. Whole numbers. I'm hoping as you get there, rowing speed of 6, the water speed, the current speed 2. 2. What's up?
Wait, how did you get sick?
Okay, so let me ask you, Caroline, what'd you multiply by?
-4.3.
So -4 and 3, right?
-12x minus 12y.
Okay, well, let me, here we go. So you got -12 minus 12, whatever your variable is, equals -96.
Mhm.
Okay, 12 here, minus 12 again, equals 48.
Yeah.
Okay, they cancel. I'm left with -24 is equal to
-48.
-48. So C equals 2. Or the current, whatever you had for the current equals 2, right?
Yeah.
Okay, so the current equals 2. So now I go back. Did you plug it into the first one?
Oh, I think I plugged it into the wrong thing.
So you have 3. Whoa, what happened there?
3.
No. Which equation did you plug it into?
Never mind.
You sure?
I'm embarrassed.
Okay.
Yeah, I know.
All right, as long as you know what you did. Anybody else have an issue? 6 and 2? Okay, we're going to practice this on Monday. The quiz is on mixture motion and then the other type of problems we did, like with the cholesterol and the ice cream and the egg type stuff. That's what your quiz is on. All right? So nothing stronger than ginger ale this weekend. Please behave, be smart, do your part. Bye, guys.
Bye.